Today our focus was on surface area of composite figures. So for the given shape here, we're going to have two bases essentially of this shape, and they're not quite regular shapes because this one here has what would be a square on top of this rectangular end. Aside from the ends, which are slightly different shaped, everything else should be pretty much rectangles as we work our way around the shape. But we're going to start on the ends. And so this end is 6 tall. And it is 4 in width. And again, there's 2 of them, but also remember at the same time, which we're adding to this, there's this piece here. And since this far left side is 6 and the far right side is 7 centimeters tall, that tells me that this piece here is 1 centimeter tall. And since the bottom is 4 centimeters tall, but the top of this figure is 3 centimeters tall, that tells me that the top of this little piece is 1 centimeter in length. So the area of this little piece would be 1 times 1. So 6, and sorry, there are 2 of them because there's going to be 1 on each end. So 6 times 4 is 24 times 2 plus 1 times 1 is 1 times 2. 24 times 2 is 48 plus 1 times 2 is 2. So the area of the bases, this irregular shape we have here, is 50 centimeters squared. Well, now I need to start working on the rest of the sides. I have a bottom is one side, a right side, which is this big rectangle, is another, a teeny little top, an inside lip that we can't really see, that would be my fourth, a top to this bigger rectangle piece, which would be a 5th side, and a left side of this shape, which is facing away from us, that would be a 6th side. So I'm going to go ahead and label all of these individually as side A, B, C, D, E, and F, so that I don't forget to calculate any of them. So, starting on the bottom, the dimensions for this bottom rectangle are 4 times 12. Working up the right side now, the dimensions for this big rectangle are 12 times 7. Now working across the top, I have this thin strip up top, which we already said was a length of 1, and it's got a long edge of 12. So 12 times 1. Now this inside lip that we can't see because it would be behind the 3-dimensional shape is also 12 long, but it's got a height of 1. Now we have an edge rectangle for the top of the major portion of this shape that is 3 long and 3 wide and 12 long. And then the back side of this shape that we can't see on the 3-dimensional section would be 6 high times 12 long. And that would bring us back to the bottom if we were working our way around this shape. So we know that we have all of the dimensions necessary. So now I no longer need the image. I can simply do the calculations. 12 times 4 is 48. 12 times 7 is 84. 12 times 1 is 12. 12 times 1 is 12. 12 times 3 is 36. And 6 times 12 is 72. These are all of my dimensions of the surface areas for this particular figure. So now I just need to add them up. 50 plus 48 plus 84 plus 12 plus 12 more plus 36 plus 72. All of these numbers added together give me 314 centimeters squared. Problem number 2. Problem number 2 goes ahead and tells me that the area of the base for this particular piece of this shape is 5.6 feet squared. And the reason why it did that is because it didn't need you trying to have a whole bunch of extra numbers that you didn't know where they went on this image. So I minimized some of the numbers by giving you the area of the base. I'm going to break this image up into 2 pieces because if I cut this top piece off, I see a triangle here and a triangle over here on the left, which means I have a triangular prism. And I can find all of the pieces for a triangular prism. A triangular prism, as we discussed in class, has 2 bases. And we have already been given the area for one base, which is 5.6 feet squared. So I'll just simply need to multiply that times 2. Which would equal 11.2 feet squared. Now the next piece that I need to figure out for this is going to be the 2 rectangular portions of my triangular prism. And remember that we don't need to find the bottom of this rectangular prism where it attaches, or bottom of this triangular prism where it attaches to the rectangular prism, because that's no longer part of the surface area when the 2 images were joined. So, my indicators here tell me that this length of the pitch is 3.6 feet, and this length is 3.6 feet. So I'm going to have a side A and a side B on my triangular prism. Side A is 3.6 feet times the length of this rectangle, 4 feet. And side B is also 3.6 feet times 4 feet. So 3.6 times 4, that equals 14.4. So this one would also equal 14.4. And now we can work our way down to the rectangular prism. Rectangular prism is going to have 1, 2, 3, 4, and the bottom would be 5 sides that we need to calculate area for. I know that this end here, visually on my right side, is going to be equivalent to this end opposite of it on the left side. So I'm going to go ahead and call that my base, since it's the first rectangle I identified. And there's 2 of those. And its dimensions are 3.6 times 2 high. Remember, we have 2 of those, so I'll multiply that by 2. I also have on my image here, if I create another box here, I'm going to have a front and a back. So a back and a front that are the same. So I'm going to label that as front and back. And my front is 4 feet long and 2 feet high. And my front is the same as the back, so times 2. And then the last thing I need to figure out is the bottom of this image. So we see that as 3.6 times 4. And like we mentioned before, this will not have a top because the top of my rectangular prism is fused with the bottom of my triangular prism, and so they're no longer part of the surface area. I'm simply calculating surface area by the exterior sides of this shape. So now let's come back over to our calculations so you can see all that we're working with. 3.6 times 2 times 2. That's going to equal 14.4. 4 times 2 is 8 times 2. That'll equal 16. And then 3.6 times 4. Well, we already know that's 14.4. So we have all of our pieces of information. Now I simply need to just add them up. So 14.4 plus 14.4 plus 14.4 plus 14.4, or if you picked on by now, I can call that 14.4 times 4 because I have 4 values with the same numeric number, plus 16 plus 11.2. So my solution is 84.8 feet squared. Number 3, I have a big rectangle with a little rectangular cylinder on top of it. So the first thing I'm going to do is calculate the area of my big rectangular prism. So I'm going to ignore for the moment the fact that this little one is even there. And if I were to cover it up, then I could say, okay, now I have a big rectangular prism. What's the surface area of all those sides? Well, it'll start with 12 times 9 for one of my bases. So let's go ahead and calculate top and bottom. Twelve times 9. And I'm going to calculate 2 of those for right now. Now we should be able to notice that this little rectangular prism is sitting on top of the big one. So there's going to be a portion of its area that we don't need for the big rectangular prism. I'm going to subtract that in just a little bit here. For now, I'm going to find all of the surface area and then subtract it. Top, bottom, left, right, front, and back. So my right side will be over here. It's going to be 20 high by 9 with an equivalent left side. My front will be 12 times 20 with an equivalent back. So let's figure these out. 12 times 9 times 2 would be 216. 20 times 9 times 2 would be 360. 12 times 20 times 2 is going to be 480. Now let's find the area of my small rectangular prism. And you'll notice from the small rectangular prism that since it's sitting on the big one, first of all, we need to reduce the area of the big rectangular prism's top by the area of the little rectangular prism's top. Secondly, we need to not calculate in the area of the little rectangular prism's bottom. So how am I going to accomplish both of those in one step? Well, here's how I'm going to do it. I'm going to recognize that the top of the little rectangular prism is the same amount of area as the bottom. And rather than deal with subtracting that space from the big rectangular prism, I'm going to assume that that space was already part of the big shape and just not add it in when I calculate the small rectangular prism's area. And it makes a lot more sense, I think, when you look at actual two objects together. When you hold the two objects together and you look down on it from above, the actual surface area of the big shape is what you're calculating. So I'm going to go ahead and leave all of my big rectangular prism answer alone and just calculate the surface area for my four sides of my small rectangular prism. So I would have one side that is 3 millimeters by 9 millimeters tall. And it would have an opposite side that's also that. So I can say times 2. I would have another side that's 4 millimeters times 9 millimeters tall. And it would have a back side that's also that same dimension, so we can multiply it by 2. So 3 times 9 times 2 equals 54. 4 times 9 times 2 equals 72. Add the two together and we get 126. We need to add these together. We get 216 plus 360 plus 480 gives me 1056. And then when I finally combine the surface areas of my two shapes, my grand total is 1182 millimeters squared. Now I do realize this takes a little bit of time to get used to, and they take a little bit of work to work through, and sometimes visualizing the 3D space and the dimensions for each side can be a little bit tricky because you truly have to follow where the labels are. And I know for me even, I will be looking at a shape in one fashion, and then after I've done a calculation and look back at the shape, my eyes have rotated the three-dimensional aspect of that shape, and it makes it hard for me to remember what area I have already calculated. So you truly have to be careful on paying attention to where you have started gathering information, labeling as much as you can, and then being careful in your mathematical calculations. But you can do it. I have confidence. We will go over these tomorrow. I'll let you work on the last two on the back by yourself.